Gasoline, ʻɡæsəliːn, also known as petrol, ʻpɛtrəl, outside of North America, is a transparent, petroleum-derived liquid that is used primarily as a fuel in internal combustion engines. It consists mostly of organic compounds obtained by the fractional distillation of petroleum, enhanced with a variety of additives. On average, a 42-gallon barrel of crude oil yields about 19 gallons of gasoline when processed in an oil refinery, though this can and does vary based on the crude oil sources assay. The characteristic of a particular gasoline blend to resist igniting too early is measured by its octane rating. Gasoline is produced in several grades of octane rating. Tetraethyl and other lead compounds are no longer used in most areas to regulate and increase octane rating, but many other additives are put into gasoline to improve its chemical stability, control corrosiveness and provide fuel system cleaning, and determine performance characteristics under intended use. Sometimes, gasoline also contains ethanol as an alternative fuel, for economic or environmental reasons. Gasoline, as used worldwide in the vast number of internal combustion engines used in transport and industry, has a significant impact on the environment, both in local effects and in global effects. Gasoline may also enter the environment uncombusted, as liquid and as vapors, from leakage and handling during production, transport and delivery, from storage tanks, from spills, etc. As an example of efforts to control such leakage, many storage tanks are required to have extensive measures in place to detect and prevent such leaks. Gasoline contains benzene and other known carcinogens. Better source needed. Octane rating. Spark ignition engines are designed to burn gasoline in a controlled process called deflagration. However, the unburned mixture may auto-ignite by detonating from pressure and heat alone, rather than ignite from the spark plug at exactly the right time. This causes a rapid pressure rise which can damage the engine. This is often referred to as engine knocking or end gas knock. Knocking can be reduced by increasing the gasoline's resistance to auto-ignition, which is expressed by its octane rating. Octane rating is measured relative to a mixture of 2,4-trimethylpentane and N-heptane. There are different conventions for expressing octane ratings, so the same physical fuel may have several different octane ratings based on the measure used. One of the best known is the research octane number. The octane rating of typical commercially available gasoline varies by country. In Finland, Sweden, and Norway, 95 RON is the standard for regular or unleaded gasoline, and 98 RON is also available as a more expensive option. In the UK, ordinary regular unleaded gasoline is 95 RON, premium unleaded gasoline is always 97 RON, and super unleaded is usually 97-98 RON. However, both Shell and BP produce fuel at 102 RON for cars with high-performance engines, and in 2006 the supermarket chain Tesco began to sell super unleaded gasoline rated at 99 RON. In the US, octane ratings in unleaded fuels can vary between 85 and 87 ARCI for regular, through 89-90 ARCI for mid-grade, up to 90-94 ARCI for premium. South Africa's largest city, Johannesburg, is located on the high veld at 1,753 meters above sea level, so the South African AA recommends 95 octane gasoline at low altitude and 93 octane for use in Johannesburg because, the higher the altitude the lower the air pressure, and the lower the need for a high-octane fuel, as there is no real performance gain. The octane rating became important as the military sought higher output for aircraft engines in the late 1930s and the 1940s. A higher octane rating allows a higher compression ratio or supercharger boost, and thus higher temperatures and pressures, which translate to higher power output. Some scientists even predicted that a nation with a good supply of high-octane gasoline would have the advantage in air power. In 1943, the Rolls-Royce Merlin Aero engine produced 1320 horsepower using 100 ron fuel from a modest 27-liter displacement. Towards the end of the Second World War, experiments were conducted using 150 ron fuel, obtained by adding 2.5% aniline to 100 octane of gas. Stability. Quality gasoline should be stable for 6 months if stored properly, but gasoline will break down slowly over time due to the separation of the components. Gasoline stored for a year will most likely be able to be burned in an internal combustion engine without too much trouble, but the effects of long-term storage will become more noticeable with each passing month until a time comes when the gasoline should be diluted with ever-increasing amounts of freshly made fuel so that the older gasoline may be used up. If left undiluted, improper operation will occur, and this may include engine damage from misfiring or the lack of proper action of the fuel within a fuel injection system, and from an onboard computer attempting to compensate. Storage should be in an airtight container that can withstand the vapor pressure of the gasoline without venting at a stable cool temperature. When gasoline is not stored correctly, gums and solids may be created, which can corrode system components and accumulate on wetted surfaces, resulting in a condition called stale fuel. Gasoline containing ethanol is especially subject to absorbing atmospheric moisture, then forming gums, solids, or two phases. The presence of these degradation products in the fuel tank, fuel lines plus a carburetor or fuel injection components makes it harder to start the engine or causes reduced engine performance. On resumption of regular engine use, the buildup may or may not be eventually cleaned out by the flow of fresh gasoline. The addition of a fuel stabilizer to gasoline can extend the life of fuel that is not or cannot be stored properly, though removal of all fuel from a fuel system is the only real solution to the problem of long-term storage of an engine or a machine or vehicle. Some typical fuel stabilizers are proprietary mixtures containing mineral spirits, isopropyl alcohol, 1,2,4-trimethylbenzene, or other additives. Fuel stabilizer is commonly used for small engines, such as lawn mower and tractor engines, especially when their use is seasonal. Users have been advised to keep gasoline containers more than half full and properly capped to reduce their exposure. To avoid storage at high temperatures, to run an engine for 10 minutes to circulate the stabilizer through all components prior to storage, and to run the engine at intervals to purge stale fuel from the carburetor. Gasoline stability requirements are set in standard ASTM D4814414B. The standard describes the various characteristics and requirements of automotive fuels for use over a wide range of operating conditions in ground vehicles equipped with spark ignition engines. Energy content. Energy is obtained from the combustion of gasoline by the conversion of a hydrocarbon to carbon dioxide and water. The combustion of octane follows this reaction. 2C8H18 plus 25O2 16CO2 plus 18H2O. Gasoline contains about 42.4 megajoules per kilogram, quoting the lower heating value. Gasoline blends differ, and therefore actual energy content varies according to the season and producer by up to 4% more or less than the average. According to the US EPA, on average, about 74 L of gasoline are available from a barrel of crude oil, varying due to quality of crude and grade of gasoline. The remainder are products ranging from tar to naphtha, a high-octane rated fuel, such as liquefied petroleum gas, has an overall lower power output at the typical 10:1 compression ratio of a gasoline engine. However, with an engine tuned to the use of LPG, the power output can be improved. This is because higher octane fuels allow for a higher compression ratio without knocking, resulting in a higher cylinder temperature, which improves efficiency. Also, increased mechanical efficiency is created by a higher compression ratio through the concomitant higher expansion ratio on the power stroke, which is by far the greater effect. The higher expansion ratio extracts more work from the high-pressure gas created by the combustion process. An Atkinson cycle engine uses the timing of the valve events to produce the benefits of a high expansion ratio without the disadvantages, chiefly detonation, of a high compression ratio. A high expansion ratio is also one of the two key reasons for the efficiency of diesel engines, along with the elimination of pumping losses due to throttling of the intake airflow. The lower energy content of LPG in comparison to gasoline is due mainly to its lower density. Energy content per kilogram is higher than for gasoline. Molecular weights of the above reagents are C8H18 O232, CO244, H2O18. Therefore 1 kg of fuel reacts with 3.51 kg of oxygen to produce 3.09 kg of carbon dioxide and 1.42 kg of water. Density. The density of gasoline ranges from 0.71–0.77 kg L, higher densities having a greater volume of aromatics. Since gasoline floats on water, water cannot generally be used to extinguish a gasoline fire unless used in a fine mist. Finished marketable gasoline is traded with a standard reference of 0.755 kg L, and its price is escalated according to its actual density. Chemical analysis and production. Gasoline is produced in oil refineries. Roughly 19 U.S. gallons of gasoline is derived from a 42-gallon barrel of crude oil. Material separated from crude oil via distillation, called virgin or straight-run gasoline, does not meet specifications for modern engines, but can be pooled to the gasoline blend. The bulk of a typical gasoline consists of hydrocarbons with between 4 and 12 carbon atoms per molecule. It is a mixture of paraffins, cycloalkanes, and olefins, where the usage of the terms paraffin and olefin is particular to the oil industry. The actual ratio depends on the oil refinery that makes the gasoline, as not all refineries have the same set of processing units. The crude oil feed used by the refinery, the grade of gasoline, in particular, the octane rating, the various refinery streams blended to make gasoline have different characteristics. Some important streams are straight-run gasoline, usually also called naphtha, is distilled directly from crude oil. Once the leading source of fuel, its low-octane rating required lead additives. It is low in aromatics, containing some cycloalkanes and no olefins. Between 0 and 20% of this stream is pulled into the finished gasoline, because the supply of this fraction is insufficient and its run is too low. The chemical properties of the straight-run gasoline can be improved through reforming and isomerization. However, before feeding those units, the naphtha needs to be split in light and heavy naphtha. Straight-run gasoline can be also used as a feedstock into steam crackers to produce olefins. Reformate, produced in a catalytic reformer, has a high octane rating with high aromatic content, and relatively low olefins. Most of the benzene, toluene, and xylene are more valuable as chemical feedstocks and are thus removed to some extent. Catalytic cracked gasoline or catalytic cracked naphtha, produced from a catalytic cracker, with a moderate octane rating, high olefins content, and moderate aromatics level. Hydrocrackate, produced from a hydrocracker, with medium to low octane rating and moderate aromatic levels. Alkylate is produced in an alkylation unit, using as feedstocks isobutane and alkenes. Alkylate contains no aromatics and alkenes and has high MON. Isomerate is obtained by isomerizing low-octane straight-run gasoline to isoparaffins. Isomerate has medium RON and MON, but nil aromatics and olefins. Butane is usually blended in the gasoline pool, although the quantity of this stream is limited by the RVP specification. The terms above are the jargon used in the oil industry and terminology varies. Currently, many countries set limits on gasoline aromatics in general, benzene in particular, and olefin content. Such regulations led to increasing preference for high-octane pure paraffin components, such as alkylate, and is forcing refineries to add processing units to reduce benzene content. In the EU, the benzene limit is set at 1% volume for all grade of automotive gasoline. Gasoline can also contain other organic compounds, such as organic ethers, plus small levels of contaminants, in particular organosulfur compounds, but these are usually removed at the refinery.